Hey everyone, welcome to this short tutorial where we are going to discuss how anyone for any application can make their chatbots more fault resistant. The idea of this short tutorial is just give some ground rules and some small system changes that everyone can make in their chatbot deployments, which allows them to do multiple things, reduce hallucination, make sure that the user experience is better, and a number of other stuff. So yeah, let's get started. Alrighty. First thing before we begin, probably everyone should understand is in today's world, every enterprise chat application or every successful chat application that we see is powered by a large language model is a better representation of doing a good enterprise RAG, the retrieval augmented generation. So if it's a chat application, what we are actually looking for is a large language model agent which is able to retrieve the relevant knowledge at any moment of time that is needed by a different application, whether it might be a user interacting with a customer service bot, or whether it might be an internal employee trying to find an information about something and interacting with the chatbot. So a chatbot has started replacing different documentation, different user interfaces, and has become a more of a human-alike interface for any user to get the required knowledge or to solve the required problem at any moment of time. So with that, let's start looking at first getting our basics right so that we understand what the problems that we normally face when we are trying to deploy a RAG powered chat application. And then we'll look at how we can make it really strong, how we can make it fault tolerant, and so that it works, and also make sure that you are covered for all the risks that it might bring to you in case we don't deploy it with lots of small system changes. Alrighty, so with that, let's look at this architecture which represents an archetype of any enterprise chat-based application deployment as of now in 2024. In essence, it will have lots of small components, but what we are mainly looking for is a small or probably a good foundational model which is able to converse with another human at the other end in a human-like fashion. And second, you want to make sure that the conversation that happens actually aligns with the brand persona or the objective or the application for which you are trying to deploy this chat application. These are the only two main things, and then there are also sub components that we will discuss as we move forward. But first, let's look at this architecture. This architecture is quite a simplistic representation, and most of the enterprise RAG applications that you will see fall into this bracket somehow. It might have a different way of looking at it, but in essence, all of them are quite similar. So all of them will have a UX layer where any customer will interact with another large language model or with a large language model through a UX layer, which might be a computer, which might be a mobile application, which might be a tablet. And this conversation with the large language model goes through a prompt, essentially engineered by the AI engineers or the application developers, which tells the large language model how should they respond, right? It might be literally that you are a chatbot for a insurance company and you are only supposed to answer questions related to products. Don't ever answer anything that's other than that. Then we need something in the back end which gives the large language model the power of the knowledge of the organization, right? Because large language models are knowledgeable, but they don't have specific knowledge about domains, about customers, about different organization specific documents. So for that, we need the RAG layer. And at the backend, we need a way of converting the organizational information into vectorized knowledge. So that vectorized knowledge, which is something that we can use to feed relevant conversations to the large language model. This will become much more clear as we move forward, but think of it literally in the simplistic term in these three ways: a UX layer, a large language model supported by a prompting layer, and at the backend we have a RAG layer, retrieval augmented generation, which allows the large language model to get the required knowledge that they need at any moment in a conversation to make sure that they are feeding the right information to the end user. With that info, let's start looking at some of the risks or some of the faults that might creep into a chatbot application powered by RAG for any enterprise. And these are the risks that are relevant for everyone, even if suppose it's a single developer or a developer team of hundreds of people, that everyone should recognize and probably find steps to solve it. But we can't solve them until we know them. So with that, let's move and try and have a look at some of the risks that plague them. So there are various risks, but I've captured it into a small embodiment of 5 major risk types. And these risk types are: first, non-deterministic output. Large language model is a next token prediction machine. Although there are various ways you can control and make them more deterministic, but still, as of now, every output that comes out is a non-deterministic output for large language model. Second, hallucination. Large language model can hallucinate because they have been trained to predict the next token, right? So there is a high possibility that whatever they are saying next might be a hallucination, might not be a truth. Third, persona misalignment. Every brand, every business wants a conversation with their customers aligned with their values, their brand persona. But with the first 2 risks, third one becomes a bit harder to do. And you don't want your customers to have a bad experience. So persona misalignment is a big risk that everyone faces. Fourth, scope drift. One of the major problems that I have seen lots of chatbot developers face is scope drift. That, for example, you deploy a chatbot for just providing product information for the customers, and customers start asking it for prices. And then it becomes a more hard battle, which might be legal, which might be customer centric, and so on and so forth. So it's very important that you should be able to align your customers to a very specific scope. But it's a hard thing, but you can do it. And final, lack of composition and generalization. I have mentioned it here because, as per me, this is one of the things that most of the large language models do a very bad job at, that is composition generalization, that in an easy term is essentially multi-hop questions, where you might ask it something, but it might not be a straightforward question, but more a kind of conversation. For example, what is this presentation about where we are going to talk about large language model? Can you tell me about the users, or can you tell me about the person who is giving the talk? Oh, it's confusing to humans, right? But the humans can still take the last part of the question and still say, okay, no, Shubh is presenting it. So, but large language model can literally go crazy and kind of then start giving some really hallucinated outputs. So yeah, these are 5 major risks that we all have to watch out for. And going forward, we'll look at some of the very strong measures or very important measures that we can take to mitigate them. All right, with that, let's start delving deeper into why we are having this presentation for. Looking at the guardrails. This, I reckon, is something that's probably the most important component when we start designing a system that is a RAG-based chat application. I call it a Veracity control center, but you might call it anything. But in essence, it's a subsystem that sits between the UX layer and the rest of the system, which its main objective is making sure that the large language model doesn't go nuts. That's about it, right? Now, to think of it, how might a large language model deviate away from giving a right response? So in essence, it has an input and it has an output, right? The input might be the questions that are coming out from a user or from any other subsystem and so on and so forth. It might be someone asking it, can you tell me what are the 3 products for, let's say, a retail shop called as X? It might be someone feeding it a log file. It might be someone uploading a different .exe file to it, and so on and so forth, right? So there are n number of different vectors that you might have to think of when a large language model is being fed input, and you should make sure that you cover for all the risk scenarios. And second, as I mentioned before, a large language model is a non-deterministic entity. So when it's throwing out an output or throwing out a response, we will all need to make sure that we don't allow the response directly without any tests or any checks to reach the end user, right? So these are 2 very simple way to think about this Veracity control center that I have introduced in this architecture. It needs to sit somewhere between the UX layer and between the large language model, right? I have placed it differently. You can place it in a different way if you want, but in essence, that's the job it should do. With that, let's do a deep dive into the Veracity Control Center, which manages grounding, scope drift, and adversarial attacks. So it essentially covers our large language model powered application from different attacks across different vectors. So first component in that is a fact checker, which is essentially there so that making sure that a large language model, if it's giving something out that doesn't align with the version of fact that an organization or a company has, we can catch it, right? So a fact checker can be deployed in multiple ways, but what I suggest is leverage a mini RAG to cross-check any fact that large language model send to customer. So anywhere where a conversation is happening and you detect a fact that is being sent to a customer, we need a subsystem which can pick up an entity and kind of check it from a backend system. It could be a SQL engine, which literally takes an entity, runs a SQL query, gets the corresponding data from the backend service and says, oh no, it's wrong, and sends a templated answer back to the user. Or it could be a simple way of literally keeping a small cache of some small key entities in there and literally checking all the responses against that. In case the fact don't align, as I mentioned here, you need internal alerting and replies with a generic output, and you need a good amount of human-annotated test set to check that. Second is persona fine-tuner, which should be quite easy to build, but it essentially is a way of developing a predictive entity which can, depending upon a natural language response, it can check whether the persona is toxic, doesn't align with the brand, and so on and so forth. And whenever something like that happens, again, you have to go back to that and gives a templated answer. Third is confidence estimator, which essentially check if there is a deviation away from a normal confidence level of large language model. And if it's there, you raise an alert. 4, 5, 6 are not optimizing the response of an LLM, but optimizing the customer query, because the response of an LLM depends upon the customer's questions that are being asked. So first is query sanitizer, which removes sensitive information. Suppose the customer sends out a credit card information and so on and so forth. You don't need to send that across to a large language model, which might be either be hosted by someone like an OpenAI or Anthropic and so on and so forth. Handles probabilistic queries and route sensitive problems to human experts. There might be some problem which large language model is really bad at answering, so you can detect them early and send it to a human expert. 5 and 6 are around modifying a query to more align with what your prompt is, which is also called as meta prompting. Like literally, when a question is being asked, if you think a question that is being asked by a user doesn't align with the kind of questions that a large language model plus the human written prompt expects, you modify the query based on a set of small programs that you might have. Okay, you can do it in multiple ways. I won't get into detail here. Maybe in a future video, we can go into one of those. And number 6 is adversary detector. You detect adversarial questions and it will reply with a templated answer. There are lots of adversaries out there in the wild and who might try to literally fool a system into doing something which they can take an advantage of. And this is more aligns with a cyber threat detection and so on and so forth, which has expanded the horizon with the introduction of large language models in the spectrum. But this is also something that is a very important part of the optimizing the customer query. Alrighty, now let's pick one small subsystem or one small component and go a bit deeper into it so that everyone understands how all of these small things are built. One thing to understand is all of these small subsystems or problem solvers, like what I mentioned, fact checker, persona fine-tuner, confidence estimator, and so on and so forth, they all need a build of their own, right? So you have to think of different problems and you have to build predictive machines to detect these problems. That's the way to think about it. Let's talk about confidence estimator. That will give you a good general intuition of how you might go on and build these. First step is build a test set, right? A test set for any of the teams out there is what are the problems or what are the questions that you expect your chatbot, this is power of large language model, to answer. That's your test set, right? So it needs to be a team effort. It's not something that you should probably rush through, but it's something that you build on. You probably source it from past experiences, past organizational data. In some cases where you don't have, you probably sit together as a team, bring your domain expertise together and build a test set. It needs to capture lots of things. It needs to capture across different domains, problems. It needs to capture edge cases and so on and so forth. But this is what test set is your moment of truth. That is what actually will help you identify where, if your large language model powered application is going wrong, this is what it will all get down to. Okay. So make sure you have a good test set which you can use to leverage and identify different things, different problems within a large language model application. So for confidence estimator, if you first need a test set, second thing make sure you have a good granular segmentation of different kind of problems in a test set. It could be separated by product type, it could be separated by geography, it could be separated by customer, so on and so forth. And third step, which I reckon not many teams are doing, is simulation. It's a bit costly, but the price of tokens have come down rapidly in last 1 year. So you can always have a pre-built time where you are simulating a large language model and trying to identify gaps in it, trying to identify what are the confidence score it's spitting out for the questions that are relevant to you, right? So when you do that, almost all large language model providers have a confidence estimate that they spit out with the tokens. And most often than not, if you are keeping your other hyperparameters same, you will see for similar questions, similar kind of confidence estimates being thrown out by large language models. And this is what your benchmark is, all right? Your benchmark is not high confidence. Your benchmark is not low confidence, because having a high confidence for large language model has its own set of problems and is similar to a low confidence. For the right answer to your test set, what are the corresponding confidence intervals that you identify are good? That's about it, right? I will talk about it later, maybe in one of the videos where we will build a confidence estimator from scratch. But to think of it, it's a benchmark identifying what is the good probability of the next token for the correct answer for your test set, all right? And finally, after the simulation, you need to do a production time comparison. So wherever you observe that some of the answers of a large language model deviate away from similar kind of questions that you have tested in the simulation, that is where you kind of go in and raise an alert. And the alert might be different things. Alert might be just an alert so that someone can look at these things. It could be literally a fail safe where the answer now switches to a templated answer, and so on and so forth. But confidence estimator is a great way to build your estimate around your domain about what a large language model is able to do, and with what confidence, so that you can accordingly build your whole chatbot application. This is just a simplistic mock plot, so that how it might look like. Once you have the log profs that the large language model spits out, you might have lots of samples in which you might want to separate and say, okay, these are the samples that I might want to allow to pass through the user. These are what I might not. And yeah, depending upon your simulation and pre-built learning that you have had, you can have different benchmarks to do different stuff. You could even have multiple benchmarks. You could say, okay, if it's this benchmark, I'm sending it as an alert. If it's this benchmark, I'm not allowing the response to go through, and I'm actually sending a templated answer. So yeah, depends upon how you scientifically think about the problem. And finally, let's look at what we learned today. All right, it's a very high level overview of how you might want to develop a system around large language model to make sure you are able to create a great experience for your user, but also safeguarding against multiple risks. So what we learned is at a high level how a RAG-powered LLM works. We learned how fine-tuning prompt engineering and RAG strategies are actually good, but they also introduce lots of huge risks in there. We learned about 6 guardrails which can be implemented. And I will also talk about lots of other guardrails in the future videos. So we also went deeper into confidence estimation, which is one of the guardrails which I have seen to work really well, provided you build on top of it. Don't think of that you just will build a confidence estimate and it will always work for you, because it's essentially a system, right? Your large language model versions might change, your test set might change. So keep on building on top of it. But if you have a good hands on that, over a period of time, you will see you will become really successful. Does not matter how the large language models evolve over a period of time. With that, I will just stop and say thank you. Thanks for your time and see you next time. Cheers. Bye.